lights.
Okay, do we want to back one off to 250,000?
Planetary geologist Pete Schultz formulated a new experiment to simulate what impact craters look like under the surface.
1.1 feet.
At the Vertical Gun Range at NASA's Ames Research Center, Schultz is using a massive 30 caliber light gas gun that shoots projectiles at various targets inside a vacuum chamber.
Today, we're going to try to look inside a crater as it forms. And to do this, we're going to use a clear block. It's transparent, so we actually get to watch the crater as it grows, but from the inside rather than from the outside. This little bead is simulating an asteroid that's going to slam into the surface of the Earth. So let's get inside. We're in the impact chamber. This is where everything happens. The little projectile bead is going to be coming in at around 4 miles per second. We're going to hammer this transparent block. We're going to be looking at everything that happens below the ground when an asteroid hits the surface of the Earth.
Outside the chamber, high-speed cameras will document the deep impact from various angles.
Are the Shimatsu's all up down there?
In the control room, Schultz watches the monitor with nervous anticipation.
High voltage?
The vertical gun launches the glass bead projectile into the acrylic block.
Sweet. Wow, okay, that is just frickin' gorgeous.
The experiment was a smashing success.
Kapow! So here we actually have the impact, but now we see this vapor plume. This is really hot gas. It's about a temperature close to the surface of the sun. And then as it moves away, it cools, and now we begin to form the crater with the ejecta coming out. And we're watching the crater actually begin to form on the inside. That is awesome. Okay, I want to see what you did. Oh man, did we bust this up. Now we can look to see how these cracks develop through time. So if this were a big impact, these cracks would grow where the entire crater could then collapse inward and fail.
Impact experiments at the Vertical Gun Range shed light on the large-scale destruction caused by asteroids that have fallen from space.
When we see an impact, it's not just the cracks and cracking. You will also see the vapor plume expanding. That affects life. That affects survival. If this impact occurred on Earth and was large in scale, it would simply fry the atmosphere. It would send debris out, and as it hits the Earth, again, it would cause more devastation.
Scientists have discovered that impacts from space have affected the evolution of life on Earth.
We know that, in fact, the flux of meteorites hitting the Earth was much higher in the past than it is today. And in fact, there have been known instances, for example, the large impact event 65 million years ago at the Cretaceous Tertiary boundary.
$65 million years ago, an asteroid the size of Mount Everest struck the Yucatan Peninsula in Mexico with the energy of a 100 million megaton bomb. It created a 100-mile wide crater underwater that was finally discovered in the 1980s. Scientists have determined that the asteroid impact ignited atmospheric events that may have led to the mass extinction of 75% of all prehistoric species, including the dinosaurs.
There were a lot of potential effects that could have led to the extinctions. Heating of the atmosphere, for instance, by the ejecta, perhaps leading to wildfires. The poisoning of the atmosphere from the gases produced from the vaporized asteroid. It was every ecological disaster you could think of all happening at the same time.
But was this the last time an asteroid triggered a mass extinction? A controversial new theory suggests a space rock was responsible for the disappearance of the Ice Age megamammals of North America. Scientists are dying to know what happened 13,000 years ago. the Ice Age was slowly ending. The North American continent was inhabited with big beasts like the woolly mammoth, mastodon, giant ground sloth, and the short-faced bear. But something caused 35 major groupings of species to vanish from the fossil record. Many think the ancient Clovis people, a hunter-and-gatherer society, killed off the mega mammals. But startling new evidence suggests that an object from space may have led to the demise of the giant creatures.
13,000 years ago, the climate changed suddenly, rapidly, and dramatically. It looks like there was some type of extraterrestrial event, whether it was a large meteorite, an asteroid, or a comet exploding in the atmosphere. And all of a sudden, the planet was thrown back into a little ice age.
North America experienced a brief return to Ice Age conditions. So could there be a connection between this cold snap and the disappearance of the mega mammals? Archaeologist Ken Tankersley claims to have dug up evidence of a possible cosmic impact in Sheridan Cave, located in Cary, Ohio. It's one of only 12 known sites that have been precisely dated to the time of the late Pleistocene extinction, which was the end of the last ice age. In this deep cavern, Tankersley and his team have discovered the burned remains of more than 60 species of plants and animals from that time period, including hunting weapons of the Clovis culture.
I don't believe it. This is a Clovis bone point. It's manufactured from a mega mammal rib, probably a large animal such as the American mastodon. What's fascinating about this specimen is the person who manufactured this likely witnessed the event 13,000 years ago.
Tankersley says that most of the bones he's uncovered underwent intense burning that couldn't have been caused by a mere forest fire. He says it had to have been from a colossal explosion, the kind generated by an Earth impact. And the archaeologist says he's found the smoking gun.
Oh, look what we have here.
It's hidden in a dark geological layer of dirt called the Black Mat, which dates back to 12,900 years ago. This layer has been uncovered in more than 50 locations in North America.
Note this black area. Let's see if I can trowel through here and bring out some of the more dark areas. Oh, nice. We're literally at this spot, looking at the contact of the end of the last ice age. And this oxidized layer above it, this is where the mega mammals go extinct.
Within this sediment layer, some scientists claim to have found key pieces of evidence that point to a cosmic impact. Carbon spherules created by intense fires. Shocked diamonds formed through extreme temperatures and pressures. Lonsdale-ites, rare hexagonal-shaped diamonds that are only found in meteorites. And micrometeorites, minuscule pieces of iron and nickel that come from outer space.
If we take a magnet and run it across this oxidized layer, my guess is we'll probably pick up micrometeorites. You can see how the sediment's adhering. And just as the magnet picks up iron from this layer, so does the magnet adhere to this meteorite. And this suggests, because we have a high concentration of micrometeorites in this layer and a complete absence above or below, and it's at the event of 13,000 years ago, something dramatic occurred here.
We know that all over North America there is a thin layer of dust and particles just before that black mat formed. That indicates that something happened right before the event, that is the climatic change. What is it? We still don't know exactly. All we know that something happened.
To date, no impact crater has been found. But a space rock doesn't have to reach the ground to generate mass devastation. In 1908, a rocky body slammed into the atmosphere 6 miles above Siberia's Tunguska wilderness. It released energy yielding about 5 megatons of TNT.
You can imagine what it feels like to do a belly flop off of a high diving board and you smack into the water. A small, weak, rocky asteroid will kind of undergo a similar sort of feeling as it very quickly is decelerated and braked in the dense lower atmosphere.
Immediately after the Tunguska airburst impact, an intense shockwave and hot air blast traveled to the ground and spread outward. It engulfed almost 1,000 square miles of forest. Some scientists propose that a similar scenario may have contributed to the extinction of the North American megamammals. And a comet, not an asteroid, may have been the culprit. Unlike asteroids, these dirty snowballs contain more ices and gases that tend to break up before reaching the surface.
When the theorized comet came down into the Earth and would have exploded in the atmosphere, it would have distributed amongst the ejecta that was created beneath it. It would also have seen a great variation in the deposits left behind. There would have been intense burning over a large area. Anything within the impact zone, of course, would have been devastating. At the same time, however, it would not have had immediate impact for the rest of the planet, just within the impact area itself.
This so-called Clovis comet theory suggests that profound climate changes led to the eventual extinction of the mammoths from North America. However, contrary to popular belief, a small number actually survived in various regions of the world up until around 2000 BC. And archaeological evidence indicates that the Clovis culture didn't go extinct from this alleged impact. Rather, they adapted to their changing environment.
When the large game animals that Clovis people were hunting disappeared from the landscape, people had to change the way in which they were hunting and gathering.
We may never know with certainty whether a near-Earth comet caused the Clovis event. But would modern man learn to survive after an Earth impact? We may eventually be put to the test. At this very moment, meteorite scientists scour the landscape in search of these messengers from the sky. These space rocks hold clues to impacts of the past, and as scientists are now discovering, clues to what is coming in the future. Mass extinctions, mile-wide craters, scorched landscapes, all created by objects from space. Meteorites have been intruding on our planet since the formation of the solar system. So where do we typically find these rocks?
Most meteorites, they're more easily found in dry desert regions of the Earth. For example, in the Saharan desert or even the cold deserts like Antarctica, where there's not a whole lot of vegetation or there's not a whole lot of other rocks to confuse you. However, meteorites fall everywhere on Earth with equal probability.
Cosmochemist Meenakshi Wadhwa has traveled the world in search of meteorites and now oversees the largest university-based meteorite collection in the world.
We're here looking at the collection of meteorites in the Center for Meteorite Studies at Arizona State University. There's basically 3 different kinds of meteorites. You can have stony meteorites, stony iron, or iron-rich meteorites, but all 3 kinds have at least some amount of metal. And so you can distinguish terrestrial rocks from meteorites by the content of metal in meteorites. The other way to actually distinguish a meteorite from a terrestrial rock is that you'll actually see a fusion crust on meteorites that forms on these objects when they're falling through the Earth's atmosphere.
Most of the meteorites recovered originated in the asteroid belt between Jupiter and Mars. But nearly 4 dozen actually came from our moon and the planet Mars.
The idea there is that you probably had a large asteroidal body that impacted the moon or Mars and ejected pieces of the crust of the moon or Mars, and these ejected pieces probably fell into these unstable Earth-crossing orbits, and eventually pieces made their way to the Earth that way. This is a piece of a lunar meteorite, and we believe it came from the Highlands portion of the moon. And we know that this is actually a lunar meteorite because we can compare this with actual samples that were brought back by the Apollo missions in the late 60s and early 70s.
Meteorites are precious research subjects. Although they've destroyed life time and time again, they may also have provided the chemicals needed for life on Earth.
This is possibly one of the most well-studied meteorites in the world. It fell in 1969 in Mexico. And an interesting thing to note about this rock is that these white grains are possibly some of the oldest solids that formed in our solar system as our solar system was forming 4.5 billion years ago.
These white grains, combined with the atmospheric chemicals and organic compounds on Earth, may have formed a mixture of amino acids, the essential elements of life.
So meteorites have played a very important role in possibly the formation of life on our planet and certainly the evolution of life on our planet.
Meteorites may have once provided the necessary components for living things, but they can be a source of grave concern when they hurtle down from space without prior warning. September 19th, 2007. A fiery meteorite streaked down from the sky and impacted the soft soil near the Peruvian town of Caracas, which borders Bolivia. Debris flew over 600 feet as the meteorite left a crater over 15 yards wide and 15 feet deep.
There was a gentleman riding a bicycle, and he was knocked over. Another person looking the other direction quickly turned around and saw this thing hit with a large plume rising above. In talking with the locals, the villagers, they had no idea, except they thought maybe this was some form of military action. You know, they're very close to the border of Bolivia.
Scientists reassured the locals that a meteorite, and not a missile, caused the impact crater. But immediately after the event, many villagers complained about headaches and vomiting.
They literally became ill, most likely because of sulfur or because of the fine dust that was inhaled. The vapors probably came from the material that was following the meteorite as it was coming through. It was melting, it was vaporizing as it passed through the atmosphere, and it probably, when it hit, caused an additional release of gas.
But could a space rock actually deliver harmful elements to Earth? Sci-fi movies and conspiracy theorists have proposed that meteorites could seed our planet with lethal bacteria or viruses. But what's fact and what's fiction?
The probability of this happening is very, very, very small. If that rock made it to Earth and somehow that microbial life form survived, it would find our atmosphere very toxic. Any microbe that evolved in an anaerobic and a non-oxygen environment is not going to survive long in oxygen.
The possibility that the Peruvian meteorite committed cosmic biological warfare is remote. But had this small stony meteorite impacted a nearby village, the aftermath would have been much different.
This would look like somebody had planted a roadside bomb. It would have had that effect. It opened up a hole so large that it would have swallowed several cars.
The Peruvian meteorite impact once again illustrates the unpredictability of things that fall from the heavens. And space rocks aren't the only objects that can cause bodily harm. Up to 200 heavy objects hit our planet each year. And they're not extraterrestrial, they're man-made. February 1st, 2003. The space shuttle Columbia was about to conclude its mission in space when disaster struck. The vehicle disintegrated during re-entry into Earth's atmosphere. debris fell over Texas, Louisiana, and Arkansas. All 7 crew members perished.
Because of reentry heating, it got hotter as it came into the atmosphere. Some critical components failed. That caused an overall failure of the entire spacecraft, which spread debris over a large footprint.
Spacecraft reentry disasters are rare, but space debris is not. Since the beginning of the space age, rockets have carried thousands of satellites into orbits around our planet. As a result, we've littered space with spent rocket stages, defunct satellites, fuel tanks, as well as nuts, bolts, and fragments from collisions and explosions with other debris. This abandoned space debris hovers over our planet like a cosmic garbage dump, and some will eventually fall back to the Earth. The question is when and where.
Things that re-enter the atmosphere, they do have a risk. The real risk is that something falling through the atmosphere will hit a person on the ground.